So here's a quick review of infinite limits and limits at infinity. So in this particular case, we're looking at two problems where we're approaching a number from the left and from the right. So let's start with this one. The limit as x approaches 3 from the right of 4 plus 1 over x minus 3. Now, if we were to plug in a number slightly bigger than 3, let's say 3.01, think of this. The number you get on the bottom of this fraction would be a very small number. Now imagine if we get even closer to 3. Let's say it was 3.001. Well, you'd have something like this, 4 plus 1 over 1/1000th. What that means is this number technically is getting bigger. This is like 1,000 right there. So imagine if we were doing even closer to 3, 3.0001, and then add 0, add another 0, and keep adding place values. What's happening to this number is it's getting larger and larger and larger. That means that even adding 4 doesn't make too much of a difference. Our conclusion here would be this thing's going towards infinity. Now over here, we're going at 3 from the left. So that would be like saying, let's say 2.9999. So what's going to happen here is we're going to get a very, very tiny number, but it's going to be negative, so something like this, right? So the same dynamic here happens, except this time it's 4 plus this really, really, really negative number. Let's call it negative 10,000. So you can see, just in general, theoretically speaking, that this number is going closer and closer and closer to negative infinity. Let's look at some other cases. If we're approaching infinity or negative infinity, well, now we only really need to look in one specific location, and that is at the highest powers. Because if I try to plug in a really, really large number, because you can't plug in infinity, let's say you plugged in 10 million. Well, let's suppose we plug 10 million in for x right here. 10 million squared is really large. Taking away 6 doesn't really affect the problem. So the behavior of the function isn't changed too much because of that minus 6. Same thing here, same thing there. So we really only need to look at the highest powers, the highest degree of the numerator and the denominator, right? So we can actually turn this problem into the limit as x approaches infinity of just 2x squared over x squared. And the algebra will take us to a point where that limit would just be 2. Now an interesting note, that would mean that this function has to have a horizontal asymptote at y equals 2. Let's look at this one. The idea that we're going to negative infinity in this case may or may not matter, but let's take a look at the highest degree in each. So this is like x to the 1/2, this is x to the 3rd. Well, the degree is much higher on the bottom, which means that if we start plugging in numbers, they're getting larger and larger and larger, or in this case, smaller and smaller and smaller. Negative 1 million, negative 10 million, negative 100 million. That means that this denominator is outpacing the top. So therefore, it's growing at a faster rate, leading us to a conclusion that this fraction would be so small, we could say that it's 0. Okay, let's look at one last thing. If we have a graph and we're asked to make some conclusions, we really need to be looking at some of the behavior of the function or the infinite limits. So in a case like this, we're just asking, what can we conclude about the limits of this graph? Well, here's what we must know. We know certain things like the limit as x approaches infinity of this function must equal negative 1. That's why we have this horizontal asymptote here. On the flip side, the limit of this function as x approaches negative infinity also must equal negative 1 along that horizontal asymptote. Now what about the vertical asymptote? Well, the limit as x approaches, let's say, 3 from the right is infinity, whereas the limit as x approaches 3 from the left is negative infinity. Because of these conclusions in either case, that's what's giving me that vertical asymptote. So I hope this has been helpful. Brief review of infinite limits.